Hey guys, hope you guys are doing well. Hope your revisions are going well also. For those that don't know me, my name is Daniel. I'm a GCSE and A-level maths tutor, and this is my YouTube channel, Maths with Dan, where I go through GCSE content, A-level content, so past papers, questions, and yeah, the aim is just to pretty much help you for revision. And yeah, I'm doing something new this year, which are predicted papers. So welcome to my predicted paper one for the Edexcel GCSE maths exam, which will be on the 15th of May. This is the higher version. And yeah, just like I did with the A-level predicted papers, the way I've constructed it is I've found questions from past papers, kind of tweaked them a bit, as well as that I've also created some of the questions myself as well. And the aim is just to give you another past paper to practice with, really, just to get you prepared for paper one on the 15th of May. What I'd recommend is you definitely do the paper first before watching the solutions. So the link to the paper is on my website. I'll also put it in the description, and I'll also pin a comment as well with the link so you guys can access it. And yeah, I'll be doing a paper two and a paper three as well. So I'll do a paper two after paper one, and then I'll do a paper three after paper two. And yeah, something new this year, so I'm looking forward to it. I hope you find the paper helpful, but again, try it first before you watch the video. And yeah, I don't think I have anything more to say, so yeah, let's get into the paper. Okay, so question one, part A says work out 3 and 2/5 plus 1 and 3/8. So what I'll do is, let me just zoom in a bit actually, so it's easier to look at. Okie dokie. So these are mixed numbers. We need to convert these into top heavy fractions, don't we? So 3 and 2/5, right? Remember, we're gonna do 5 times the 3, which is gonna make 15, and then we're gonna add that to 2, which is going to be 17. So it's actually 17/5, and then 1 and 3/8 is going to equal 8 times 1 is an 8, add 3, 11. So it's 11/8. So the question is actually just to work out what 17 over 5 plus 11 over 8 is. So how do we do that? We need a common denominator. Let me just zoom out a little bit as well. Um, Common denominator between 5 and 8. So we times them together because they have no common factors. That's just going to be 40, isn't it? So 40 would go there, 40 would go there. And now, how do I go from a 5 to a 40? We have to times by 8. So that means I have to times 17 by 8, don't I? So let me work out what that is quickly. 17 times by 8. 7 eighths are 56. So put the 6 there, carry the 5. 8 times 1 is an 8. Add the 5, 13. So it's 136, isn't it? So 136 there. And then 8 to a 40 is times them by 5. So we've got times that 11 by 5, which is going to be 55, isn't it? So now we can add the numerators, can't we? 136 plus 55 all over 40. What is that equal to? 136 plus 50 is 186. Add 5, 191. So it's going to be 191 divided by 40. And that will be part A. It doesn't say to give it as a mixed number or anything like that, so we can leave it like that. And then now part B, it says work out 2 and a third divided by 5, 6. Give your answer as a mixed number in its simplest form. So always just be aware of these questions and just make sure you get the marks. So 2 and a third, we're going to convert that to an improper fraction. 3 times 2 is 6. Add that 6 onto the 1. That's going to be 7/3. So the question is actually asking us to work out what 7 over 3 is divided by 5 over 6. Now, we're dealing with a division of a fraction. Remember, keep, change, flip. Keep that the same, 7/3. Change that division to a multiplication. Flip that fraction. So we're here. Now, what do we do? Well, we could times them across, but you could actually simplify before you do that. And I would recommend that anyway. We've got a 3 at the bottom and 6 at the top. So there's a common factor of 3. 3 goes into 3 once. 3 goes into 6 twice. So it's 7 times by 2, which is 14, over 1 times 5, which is 5. So it's 14/5, but remember, mixed number here. Don't lose that mark. How many times does 5 go into 14? It goes in twice with a remainder of 4. So therefore, it's just 2 and 4/5. And that's question one finished. Okay, so question two says find the highest common factor of 124 and 186. So first, I'm going to draw two-factor trees. So 124 is even. So that's going to be 2 and 62. This one's going to be even again. So it's going to be 2 and 31. And 31 is prime, isn't it? So I can actually say 124 is just equal to 2 squared times by 31. And then the next one is 186, right? Again, this is even. That's just going to be a 93. 2 and 93. And in this one here, I can see quite clearly there's going to be 3 here and it's going to be 31. So with that case, 186 is equal to 2 times 3 times 31. Now, when you want to find the highest common factor, just draw a Venn diagram with the factors involved. So with that being said, I'm going to put 124 here. I'm going to put 186 there. What factors do they have in common? They've got a 2 in common in both of them. So I'll put a 2 in the middle. And that's it. They only have 1, 2 in common. And that means the other 2 would go there. And the 3 would go there. And they both have that 31 in common, don't they? So that 31 will go in the middle. So the highest common factor when you've done your Venn diagram is just going to be the product of the intersection. So 2 times 31, which is equal to 62. So the answer is 62. And that's it. Okay, so we've got the universal set, and these are numbers from 1 to 12, integers from 1 to 12. Set A are multiples of 3, and set B are prime numbers. Part A says we to complete the Venn diagram for this information. Now, when you're dealing with these types of questions, as we can see, sets A and B are descriptive. They haven't actually given us the numerical values. So what we're going to do is actually write out what the actual numbers are going to be in this set. So multiples of 3 within this universal set are going to be 3, 6, 9, and 12. And then the set of prime numbers. Now, be very careful. You may be thinking that 1 is a prime number. It's not. Prime number has 2 distinct factors, the number itself and 1. Since 1 only has itself as a factor, it doesn't have 2. So it's technically not a prime number. So I'm going to start off with 2, then 3, then 5, then 7, and then 11. And these are going to be our sets. And then now we can complete the Venn diagram. So we always start with the overlap. I've got a 3 there and I've got a 3 there. So I can put that in the middle. And that is the only number that is in both. So now let's do the outer part of A, which is going to be all of the other numbers here, which is going to be 6, 9, and a 12. And then the outer part of B, the other prime numbers are going to be 2, 5, 7, and 11. So we've completed the circles. Now remember, do not forget the outside. The numbers on the outside are the numbers that we haven't looked at, which are in the universal set, right? Which is going to be a 1. We've got a 2. We've got a 3. There's no 4. We've got a 5. We have a 6. We have a 7. We don't have 8. We have a 9. We don't have 10. And we have 11 and 12. So the only numbers that are going to be on the outside are going to be 1, 4, 8, and 10. And that will give you the 3 marks for part A. Now part B, it says a number is chosen at random from the universal set, right? Part B says find the probability that this number is in the set A and then this symbol here, which is union B, right? So U means union. And what that means is that you're looking for every number that is inside the 2 circles, right? So you have to look at this part. So how many numbers do we have here? Well, just count them. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, right? So it's going to be 8 out of how many numbers are there? Well, it went from 1 to 12, so it's going to be 8 12s. And if you want, you could just simplify this, divide top of bottom by 4, you're going to have 2 over 3. Either one of these is fine. And that's it. That's question 3 finished. Okay, so question 4 says, here are 6 graphs labeled A to F. And the first part says, write down the letter of the graph that could have the equation y equals minus 1 over x. So with this one, you just need to have knowledge of your graphs right now. 1 over x without the minus sign, we call these reciprocal functions. And the reciprocal function y equals 1 over x is literally just equal to this here, like that. Right? So we've got this here. This curve in the first quadrant, and we've got this in the third quadrant here. Now, the graph of y equals minus 1 over x is actually special in the sense where it's a reflection in both axes. So if you think about it as reflected in the x-axis, right, it will look like this. If I reflect this in the x-axis, that will drop down like that. And then this one will come up like that. And then if I think about it as a reflection in the y-axis, so looking at this one as a point of reference, if I reflect that in the y-axis, then this one will go to the left like that. And then this one will go to the right, right? So you actually get the same thing. So this one, y equals minus 1 over x, are these two. These are the exact same graph, isn't it? Right? And this is just graph transformations, a topic that you really should know because I don't think the formulas or the rules are in the formula book. Anyways, so that would mean that y equals minus 1 over x is going to equal C, this one here. So I'll put C here. So that's part A. Part B says, y equals 2x cubed minus 3x. Now this one, again, having knowledge of your graphs is super important here because you could do it by process of elimination. Now, firstly, the highest power here is a 3. This tells me that it must be a cubic, right? Now, cubics, I know are not going to be either C or D because we've looked at them. It's the reciprocal function, so I can eliminate those. This one here is a line, right? So this is going to be in the form of y equals mx plus c. And this one here, part A, you should know that this here is a quadratic. This is y equals x squared. So it's either going to be B or F, right? Now, what do we do from here? Well, if I inspect F, right? Well, this is another one you should know. This is just y equals x cubed. And another thing to notice is that there's only one solution here, right? There's only one root, right? Whereas this graph B has 3. Now, how can you tell? Well, if I've got 2x cubed minus 3x and I want the roots equal to 0, then I'd have to solve this. And then you can take out an x and then you'd have 2x squared minus 3 inside. So you're going to have one root at x equals 0 from the front here. And then the other root would be when you solve this one. 2x squared minus 3 is equal to 0. So 2x squared is going to equal 3. That means x squared is going to equal 3 over 2. And then that means that x is going to equal plus or minus the square root of 3 over 2. So there's going to be two roots, right? One positive and one negative, and going to be the same value. So that means there's going to be 3 roots. There's going to be 0 here. There's going to be a plus root 3 over 2 there. And there's going to be a minus root 3 over 2 here. So it must be B. Now, you don't need to do all of this. And to be fair, I've not actually seen these types of questions in the exam, but I thought, you know what, it's my exam. So it's my paper. So let me do something different. But yeah, just having a general idea of your curves and the structure and how they operate would be helpful. But yeah, that's question 4. And yeah, that's it. Okay, so question 5 says, here is a solid square-based pyramid, VABCD. We've got the dimensions given. It says the base of the pyramid is a square of side 6 centimeters. The height of the pyramid is 4 centimeters. M is the midpoint of BC, and VM is 5 centimeters. Part A says, draw an accurate front elevation of the pyramid from the direction of the arrow. So front elevation. So imagine essentially you're just looking at this straight on. What we would have is essentially a triangle, right? And imagine it was 2D. What would the dimensions be? Well, firstly, the base is going to be 6. So all I'm going to do is draw a triangle with a base of 6. Now, let's just say each square is a centimeter. So it would be like this: 1, 2, 3, 4, 5, 6, like that. And then what would the vertical height be of this triangle? Well, the vertical height is 4 centimeters, isn't it? So I'm going to draw four boxes up from the center, which is going to be like that: 1, 2, 3, 4. And then now I'll just join the sides together and I'll rub out this middle line as well. So literally be like this, like that there, and then like that there, and then I'll just rub out this center line as well. Let me just make sure that's in the middle, just like there, and then that one is going to be just like that. And then yeah, that would be it essentially. Rub that out, and then this is going to be 6 centimeters here, and then this one is going to be 4 centimeters, like that. And yeah, that would be it for part A. Now part B says work out the total surface area of the pyramid. So let us get the actual question again, or the diagram I should say, sorry, the diagram. So I'll screenshot this and put this underneath, so I don't need to, whoops. So I don't need to keep going up and down. Okay, so surface area is just the area of all of the sides, isn't it? So all I'm going to do is work out each of the sides. So what do we have? We've got a square at the bottom, right? And then we've got 4 triangles, don't we? So let's do it here. So the square at the bottom is going to be 6 by 6, isn't it? So it's going to be 6 times 6, which is going to be 36, and that will be centimeters squared. And then we've got 4 triangles. So I'll work out the area of one triangle and then times it by 4. So the triangle in question is going to be, I'll do it like this. Now, you've got to be careful here. Let me do it like this. So the dimensions of this triangle, it's still going to be 6. But now think about it. The triangle itself, right, is going to be on this surface here. And the height of it here, right, the perpendicular height is going to be 5, isn't it? Right? So you've got to be careful. It's not going to be 4 this time because you're actually on the triangle. So it's going to be 5. So the area is just going to be half times base times height, isn't it? Half times the base times the height, which is going to be for half times 6 is 3, 3 times 5 is 15. So that would be 15. That's one triangle, and then there's 4 triangles altogether. So we would just times that by 4, would it be? 4 times 15 is 60. So therefore, the total surface area, all right, SA for surface area is going to be the area of the square at the bottom, which is going to be 36, plus the 4 sides of the triangles, which is going to be 60. 36 plus 60 is 96. So it's going to be 96 centimeters squared. And I'll just put that here as well. And that's it. That's question 5 finished. Okay, so question 6 says the diagram shows a sketch of triangle A and triangle B on a coordinate grid. Part A says given that triangle A has been translated to give triangle B, work out the value of D, the value of E, and the value of F. Okay, so this one, it's a transformation question, and luckily they've told us the actual transformation, right? The type of transformation. It's a translation, as you can see here. Now remember what a translation is. It's literally just a vector which moves one point to another by horizontal and vertical movement, right? Or both, right? So what we need to do is see if it's possible to figure out what the actual vector is. Now, if you inspect the coordinates, right, we can see that a couple of them have letters in them, so that's no use. But if you inspect very closely, you can see that you actually do have a pair of corresponding points, right, which you have both of the coordinates for. So we can use this point here to figure out what the actual translation must be, because it has to be the same throughout the points, isn't it? So with those, well, firstly, let's look at the x-coordinates. The x-coordinate is a -7 on triangle A. Then it's been shifted to give triangle B, which has an x-coordinate of 6. So essentially, you want to ask yourself, well, how do I go from a -7 to a 6, right? Well, all you're going to do is just literally take the difference. So 6 minus -7 is going to be 6 plus 7, which is 13, right? So that means horizontally, the triangle moves 13 units to the right. And now you're going to do the same for the y coordinates. Now, the y coordinate for triangle A on this point is 2. So I've got a 2 here. And then the y coordinate for this one is a 12, isn't it? So again, how do I go from a 2 to 12? You just add on 10. Now, we've got our vector, and obviously it has to be the same throughout the points. So that tells us that the triangle from A to B moves 13 units to the right and 10 units up. So now that we've got our vector, we could figure out what these points D, E, and F are. So let's start with D. Now, D is the y coordinate of this point, isn't it? And that corresponds to that point. So we've got a -5 originally, and we know that we're going up, isn't it? Because we're dealing with the y coordinates. We know that the y coordinates move up by 10. So I have to add on 10 to get what D is. -5 plus 10 is going to be a +5. So therefore, D is going to equal +5. So I put +5 there, or you can just put 5 to be honest. So that one's done, D is done. And then let's go to E, that's the next letter. So E is the y coordinate of this point here, and that corresponds to this point. Okay, so again, the original y coordinate for this point is -3. We're going up, right? We know that we go up by 10. So -3 plus 10 is going to be what? That's going to be a +7, right? So therefore, the y coordinate E, right, is going to be 7. So I'll put that there, and I'll put that there. And then we've done that. The last point we need to find is F, right? And that happens to be the x coordinate of the original triangle that hasn't been translated yet. But that's not a problem. That corresponds to this point, isn't it? Right? So what do I know? Let's say this is F over here, like that. Now, it's an x coordinate. Let's look at our vector. The vector tells us that we're moving 13 units to the right. So to get to the 9, it means that we have to have added on 13 onto F, and that will get us to 9, isn't it? Right? So essentially what we can say is that, well, F plus 13, right, must equal 9. And that must mean that F is going to equal 9 take away 13, which is equal to -4. So therefore, F is equal to -4. And that is our answers for part A. And yeah, that's it for part A. Okay, so part B says the diagram shows shape P and shape Q drawn in a grid. Part B says describe fully the single transformation that maps shape P onto shape Q, and it's 3 marks. So with this type of question here, you firstly need to list the type of transformation. As you can see, it's gotten bigger, so it's going to be an enlargement. And now when you're dealing with an enlargement, you need to state 2 other things. You need to state the scale factor, how much it's enlarged by, and also the center of enlargement. So you need to list those 3 to get all of the 3 marks. So firstly, I'm going to just write enlargement, because that is the type of transformation. That will give me 1 mark. So enlargement. Okay. Secondly, the scale factor. how much has it been enlarged by? Well, this side here is 2 units long. This corresponding side on the bigger shape is 6 units long. So it's gone from a 2 to a 6, so we're multiplying by 3, isn't it? And then just to confirm, you can do this side as here. This is 1 unit, this is 3 units. So each side is multiplied by 3. So the scale factor is going to be 3. So I'm going to write scale factor. We're at scale factor 3. And now to get the final mark, I need to write the center of enlargement. And the way you do that is you're just going to literally, I'm going to rub these out. You're going to draw ray lines through the corresponding points, right? So what I mean by that is, for example, these two over here, this point and that point, I'm going to draw a line through them like that. And you're going to do that for a couple of them and see where it takes you to, see where they all meet. So for example, this one goes through there. And then let's say I'm going to do this one now. These two corresponding points, which is going to be a horizontal line, isn't it? Which is going to go through 2. So we can see that actually it's going to be 0, 2, but we'll just do one more after this just to confirm. Like that. And then let's say, for example, we're going to do this one here and this one there and see where they go. So if I draw a line through like that, yeah, we can see quite clearly that they all pass, they all intersect that center of enlargement 0, 2. So therefore, you've got enlargement scale factor 3, and then you're going to say and center, and then you're just going to put 0, 2, because that's where all of the lines go through. And that will be it, and that will give you the 3 marks. And that's question 6 finished. Okay, so question 7 says the perimeter of a right angled triangle is 60 centimeters. The lengths of its sides are in the ratio 4 to 5 to 6. Work out the area of the triangle. All right, so firstly, we're dealing with a ratio, right? Now remember, a ratio is just splitting a quantity into different parts. So the fact that we've got the parts here, 4 to 5 to 6, we can add all of these together to figure out how many parts we have in total. So 4 plus 5 plus 6, that's just 9 plus 6, which is 15. So there are 15 parts in total, and this has to represent the 60 centimeters, right? So now I know that 15 parts is 60 centimeters. That will allow me to figure out what one part must be. So all I'm going to do, how many times 15 going to 60 is going to be 4 times, right? So if I divide both sides by 15, I'm going to get one part must be equal to 4 centimeters. And then from there, I can now figure out each of the lengths of our right angled triangle. So 4 parts, we're just going to times by 4. That's going to be 16 centimeters. 5 parts, we'll times by 5 will give us 20 centimeters. And then obviously 6 parts is going to give us 24 centimeters. So essentially what we have is a right angled triangle like this. Now, the longest side is 24, which is the hypotenuse. So it's going to be 24. And then to be honest, it doesn't really matter. I'll say this side is going to be 16 centimeters. And I say that side is going to be 20 centimeters. So now we've constructed our right angled triangle. We've got the dimensions. We can now work out the area. Remember, the area is half times base times the height, which in this case is going to be half times by 16 times by 20. Half of 16 is 8. So 8 times 20 is 8 times 2, which is 16.01. So the answer is just 160 centimeters squared. And that's it. That's question 7. Okay, so question 8 says BCD and AFE are straight lines. Show that BCD is parallel to AFE. Give reasons for your working. And this is a 5 marker. So what do we have here? We've got a couple of lines and we've got angles expressed algebraically. So it does look a bit tricky at first, but just think to yourself, where do you see these types of questions come up, right? Albeit the algebraic angles are not as common, but it's just the angles and parallel lines question simply, isn't it? Right? Remember, you've got a couple, you've got corresponding angles, alternate angles, co-interior angles, and so on and so forth, right? So if BCD, I'm going to write this down. If BCD is indeed parallel to AFE, I'm writing 2 lines to mean parallel, right? Then those rules would follow, right? In terms of co-interior, corresponding, and so on and so forth. So let's look at our problem. What do we have here? Well, if you look closely, this angle 30x minus 5, right? If I draw a Z like this, I can draw like a backward Z like that, then we can see that these two angles, if they are parallel, are alternate, right? Let me do it in green. Put these angles in green. These angles here would be alternate, right? So what I'm going to say is number 1, that those angles, so I'll start at the top, angle DCF, and what do we know about alternate angles? They're the same, right? So those will have to be equal, right? Angle DCF will equal angle AFC. right? And I'll just put in brackets alternate angles. Right, perfect. And as well as that, well, another thing that I can see here is that I've actually got a backwards C here as well. And that tells me that these two angles here have to be co-interior, right? And we know that co-interior angles sum to 180. So what I'm going to say now is that these two, I'm going to say angle BCF, the one at the top, plus the angle AFC, they will have to equal 180, right? And I'll just write in brackets co-interior angles. So just make sure you write your reasonings as well. Now, we've got that done. What we need to do is actually calculate what these angles are and see if they actually follow these rules, right? Now, how can we do that? Well, if you think about it, we're trying to find out what x is, so we have to form some sort of equation, right? Now, we know as a fact that BCD and AFB are straight lines. We've got two angles on this line BCD. Angles on the straight line add up to 180. So what I can say is that the 4x plus 15, this angle here, plus the 30x minus 5 has to equal 180, isn't it? So what I'm going to do is I'm going to write this here. I'm going to write angles on a straight line. On a straight line. Always write your rules. And add to 180. So that would mean that 4x plus 15 plus 30x minus 5 has to equal 180. So we've formed an equation, now we can just solve it. So let me zoom in a bit and we can do this here. Okay, so doing that, that's going to be 34 x, and then plus 15 take away 5 is 10. This will equal 180. And then now I can move that 10 over, so I get 34x is equal to 170, right? And now to get x, well, we're just going to do 170 divided by 34, isn't it? Now, these two are both multiples of 17, isn't it? So remember, on a non-calculator exam, just make things easier, cancel them, right? Or break them down into factors. That's 17 times by 10. 34 is 17 times by 2. Goodbye, goodbye. 10 divided by 2 is just equal to 5. So therefore, x is equal to 5. Now I know what x is, that will allow me to calculate what each of these angles must be, right? So let us start with, how much room do I have? Don't have that much room. Let me do it on this side here. So I'll do it here. Let me rub out everything just so it's nice. I'm gonna grab this image and then I'm gonna plug in x equals 5 into all of these angles to see what we get for each of them. So I'll do it here. Okay, perfect. So x is equal to 5, right? What would angle BCF be? If x is 5, let me write here, x is equal to 5, then that would be equal to 4 lots of 5, 4 lots of 5 plus 15, which is equal to 20 plus 15, which is equal to 35 degrees. That's fine. Angle AFC, the one at the bottom, is going to be equal to 20 lots of 5 plus 45, which is just 100 plus 45, which is 145. And then the last one, angle DCF, that will equal 30 lots of 5 minus 5, which is just going to equal 150 take away 5, which is 145 degrees. So essentially what we have here is, let me rub this out, or let me get rid of these here, and I get rid of these here, because we know what all of these angles are. So angle BCF is 35 degrees. This is 35 degrees. This angle AFC is 145, like that. And then this angle DCF, which is this one, is also 145. So remember what we were trying to prove, right? We're trying to show that BCD is parallel to AFB, and it was only parallel if these rules followed, right? So if I grab these here, and then I put this here now, then we're pretty much done, aren't we? I'll just do it here, and I'll do it, yeah, I'll do it like this, and then I'll just put those in. So all you're going to do now is just plug in your angles, right? And see, and you show that the rules are followed. So for this one here, angle DCF is 145 degrees, like that. And this is equal to angle AFC, which is 145 degrees. So that ticks, that works. And then this one, angle BCF, which is 35 degrees, plus angle AFC, which is 145 degrees, right? This is indeed equal to 180, so that works. So both of the rules are followed, and now you can say, remember, you're trying to show that the lines are parallel, so you just want to just summarize. So you're just going to say, therefore, BCD. It was BCD, isn't it? BCD, yeah. BCD is parallel to, and what was the other line again? AFE. Yeah, perfect. AFE. And that's it. And that will give you the 5 marks. Okay, so question 9 says express 5 over 3 minus x plus 2 over 2x as a single fraction in its simplest terms. And this is how many marks? It's 3 marks, okay? So this is an algebraic fractional problem. And whenever you're adding or subtracting algebraic fractions, they work the same way. They have the same logic as if you were to add or subtract normal fractions with normal denominators. So what I'd want to do is I've got a 3 and I've got a 2x. I would need to find out the LCM of these two. And all you're going to do is just multiply them together. 3 times 2x is going to be 6x. So that tells you that your new denominators are going to both have 6x underneath them, right? So 6x there, 6x there. Ask yourself, how do I go from a 3 to a 6x? Well, you'd have to times by a 2x, wouldn't you? And because fractions have to be equivalent, I have to do the same with the numerator. 5 times 2x is a 10x. So that one's done. And in this one, how do I go from a 2x to that 6x? Well, you just times by 3. So therefore, the numerator I have to do the same. So I'm going to times that x plus 2 by 3. So I'm going to get that. Perfect. So now we've done that, what I'm going to do, let me write this out neatly over here. So it's going to be 10x over 6x minus, and then now I can expand that bracket. So it's going to be 3x plus 6 over 6x. And then now we can combine the fraction because we've got the same denominator. But be very careful here. 10x, when we take away this 3x plus 6, because there's more than one term, we have to protect it. So I have to put it like this, like that. And when you just have a minus with a bracket, that is just a -1 essentially. So all you're going to do is expand that -1 here, like that. So therefore, you're going to get 10x, take away 3x, minus 6, all over 6x. So therefore, it's going to be 10, take away 3 is 7. It's going to be 7x, take away 6 over 6x. And that is it. And that's question 9 finished. Okay, so question 10 says a school recorded the times in minutes for students in class X and class Y to complete a coding challenge. Let me do it a bit. Here are the times for the 23 students in class X. So we've got them labeled 31, 32, 33, all the way to 63. So it's increasing, it's in order. Part A says complete the table to show information about the completion times of the students in class X. So we've got the median, lower quarter, and upper quarter that we need to find. Now, there are 23 students, and you can be a bit clever here. So if you think about it, right? If I was to shut it off there, like that, then how many do we have on the top row? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Which means that there are 11 underneath as well. 11 plus 7 is 22. That means that this here is going to be in the middle, isn't it? Because to the left of 45 would have 11, and to the right would have 11 too, right? So the median is just going to be 45. And now the lower and upper quartile is just going to be the middle values of each of these rows, isn't it? So the lower quartile will be the middle value from the top. So let me just shut these off, cross these out, cancel, 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 and we get here. So the lower quarter must be 40. And then similarly, it must mean that the upper quartile is going to be 54, isn't it? The middle value of all of the values to the right of the median. So we're going to have 54 here. So that's done. Now, part B, it says here is some information about the completion times for class Y. Ebony says that the students in class X completed the coding challenge faster than the students in class Y. Is Ebony correct? You must give a reason for your answer. So, with this one, what is Ebony talking about? She's talking about the completion times on average, isn't it, in general? So, what you'd want to do for this one is compare the medians, right? So what is the median for class X? It is 45, and the median for class Y is 51. So on average, it took class X a shorter amount of time to complete this coding challenge than class Y. So that does correspond. So everybody says the students of class X completed their coding challenge faster. Yes, because on average, the median is 45, and this one is greater for class Y 51. So you're just going to say yes, and then you're just going to give a reason. The median for class X is 45, which is smaller than 51. And you just write the median for class Y. Perfect. So that's part B. Now we've got part C here. It says Ebony says that the students in class X vary more in how long they took to complete the challenge than the students in class Y. Is Ebony correct? So again, this one, when you see this word vary here, what you're talking about is spread. What they're referring to is the spread. How spread out are the completion times? And you figure that out by looking at the range and interquartile range. So what I will do is let me just put this here, and then I'll put this question here, and then we can just have a look. So vary, we need to look at the range, right? So what would the range of class X be? Well, it's going to be the greatest time take away the smallest time, which is going to be this one. I'll do it here. Range is going to be equal to 63 take 31, which is just going to be 32, isn't it? And then this one, the range for class Y is going to be 65 take 30, which is equal to 35. So we can see that the range is bigger for class Y, which means that class Y's completion times vary more, right? That contradicts what Ebony is saying. Ebony is saying that the students in class X vary more, right? And again, just to confirm, let's look at the interquartile ranges for both as well. The IQR is going to be the upper quartile minus the lower quartile, which is going to be 58 take 43, which is going to equal 15 here. And then this one, the IQR for this one is going to be 54 take 40. 54 take 40, that is 14. So you can see that the range and the interquartile range for class X is smaller, right, than the ones for class Y. So to complete what Ebony was saying, let's just read it again. Ebony says the students in class X vary more. They do not, right? Because the range and interquartile range is smaller. So you're going to just say, I'll do it here. You're going to say Ebony is incorrect. Can I type there? I think I can. No, let me just write. So Ebony is incorrect. Okay. The range and interquartile range for class X are smaller than class Y. All right. And you can just put those values in just to be super safe. You could just say 32 is less than 35. All right here. 32 is less than 35. This is for the range. And the interquartile ranges, you can say 14 is less than 15. And that's it. And that will give you the 1 mark. And yeah, that's question 10 finished. Okay, so question 11 says A and B are two similar cylindrical containers. The ratio of the surface area of container A to the ratio of the surface area of container B is equal to 9 to 16. Kyla fills container A with water. She then pours all the water into container B. Kyla repeats this and stops when container B is full of water. Work out the number of times Kyla fills container A with water. You must show you're working. Okay, so this is 4 marks, by the way. We're dealing with similarity. Remember, when you're dealing with similarity objects, right? You've always got three types of scale factors, right? You will have a length scale factor, you will have an area scale factor, and you'll have a volume scale factor. And depending on what information the question gives you, determines which out of those you can initially calculate. And then from there, you can calculate the others, right? So one thing that you just need to remember is you have three scale factors. I'm going to say LSF for length, ASF for area, and VSF for the volume scale factor, right? Now, all you need to remember is I always tell my students this, right? Imagine this is a length. Let's just say this is centimeters. An area would be centimeters squared, and the volume would be centimeters cubed. So if I want the length, if I want the area scale factor and I've got the length, I would just square, right? If I want the volume scale factor and I've got the length, I would just cube, and so on and so forth, right? So again, depending on what information is given to you determines which of these you can calculate. So we have the surface areas of container A and container B. For me, that tells me that I can calculate the area scale factor. Because if you think about it, the area scale factor, I'll do it here. Well, the area of container B is 16, area of container A is 9, the surface areas, right? So the area scale factor will just be the biggest divided by the smallest, which is going to be 16 divided by 9, right? And remember, ratios and fractions are equivalent ways of expressing the same thing. So the fact that there's 9 to 16 here, I could write this as 16 over 9 or so on and so forth, right? So the area scale factor is 16 over 9. Now, remember, to go from the length to the area scale factor, right, I square. So if I want to go back to the length scale factor, then all I would do is square root, wouldn't I? So therefore, that is just going to be 4 divided by 3, right? And then in that case, remember, if we write these as ratios, remember B is on the top, A is at the bottom. This is 9 to 16. We write A and B here. And then as a ratio, I could write this as 3 to 4, right? And this is still A and B. So we've got the length scale factor from the area scale factor. Now that we have the length scale factor, remember what the question's asking us for, the number of times Kyla fills the container with water, right? It's volume we're looking for. So we actually need the volume scale factor. So let's figure that out. So volume scale factor, as we can see from here, we would cube the length scale factor, wouldn't we? So we would do the cube of this thing, 4 over 3, which is going to equal 4 cubed is 64, 3 cubed is 27. So therefore, it's 64 divided by 27. And if I want to put it as a ratio of A and B, then it would just be 27 to 64. Perfect. All right, so let's write this out here. So we've got A to B, and it's 27 to 64. Remember, we're filling container A with water and then pouring it into B. How many times can we do that? Well, all you need to ask yourself is, well, how many 27s go into 64? So we're going to do 64 divided by 27. Now, how many times does that go in? Well, it's going to be 27 and then 54, right? And then to get to 64, well, it goes in twice. There's going to be 2 here. We would have to add on 10 to get to 64, wouldn't it? So it's 2 remainder 10, essentially. So 2 remainder 10. And as a mixed number, that's just going to be 2 and 10 over 27, isn't it? So the main thing is though, it goes in twice, right? Now, remember, we're filling the container A with water and pouring it into B. So we know that after we do it twice, there's still a bit more to do. So we can't stop at 2, right? So therefore, we're gonna say that the number of times Kyla would fill the container A with water would have to be 3 times. Because 2 is not enough, we have to do it one more time. And that's it. Finished. Okay, so question 12 says find the exact value of 1 over sine 30 times tan 60. Give your answer in the form A root B over B, where A and B are integers, and this is a 3 marker. Now, we're on a non-calculate exam. We can see that we've got exact trigonometric values. So this is a question that can come up. So make sure you know how to find them. There's a couple of methods. There's a finger method, which I know a lot of students use, and there's also a grid method, which is what I like to use. But whatever you prefer is absolutely fine. So what I'm going to do is I'm going to get the exact values up for sine, cosine, and tan. There's going to be one for sine and cosine and then one for tan. So let me get that up. So I'm going to draw a big square root symbol. Let me do that. And then I'm going to just draw a line that connects it like that. And then what I'm going to do is I'm going to put sine here. I'm going to put cosine here. And I'm going to put the angles here. So 0, 30, 45, 60, and 90. These are the angles that you're going to use. And now all you're going to do is just start from 0, 1, 2, 3, up to 4. And then you're going to reverse it. 4, 3, 2, 1, and 0. And then you're going to divide this all by 2. Now, to calculate any exact value, for example, let's say I wanted the sine of 45 degrees. All you're going to do is say, okay, well, fine. Sine is here, 45 is here, and this is the number here. So all you're going to do is say it's equal to, remember that square root over 2 stays there, and you just put whatever number that is. So it's root 2 over 2. Yeah? So with that being said, we could figure out what sine 30 is, right? So sine 30 will equal, it's just going to be this one here, isn't it? 30 is there, sine is there, 1 is there. So it's going to be the square root of 1 divided by 2, which is just 1/2. So we know what sine 30 is. Now, tan. How do we get the table for tan? Now, with tan, is a little bit different. What you've got to realize, or you don't even need to realize, you can just memorize it. For GCSE, you don't need to know this, but tan, or maybe you do if you do further maths, but tan is actually equal to sine divided by cosine. So to get the one for tan, all you're going to do is I'm going to write tan here, and then I'm going to draw 2 lines like this, 2 square root symbols like that, and I'm going to divide it by another one like that. And then let me just put this down a bit. Okay. And then now, all you're going to do is literally put the angles here. So 0, 30, 45, 60, and 90. And then you're going to put, remember I told you tan is sine over cosine. Let me write here. Tan x is sine over cosine. So you're going to put the numbers for sine on the top and then the one for cos on the bottom. So it's going to be 0, 1, 2, 3, 4. And then this one's going to be 4, 3, 2, 1, and 0. Yeah. And now to get any angle that you want. So for example, we want, what do we want? We want the tan of 60, don't we? So tan of 60 just tells me, well, tan is here, 60 degrees is here. You're literally just going to line up. So you're going to do this one divided by this one. So therefore, the tan of 60 is just equal to the square root of 3 divided by the square root of 1, which is just root 3 over 1, which is just root 3. So tan 60 is root 3. So this is how you construct your table. So yeah, from moving forward for the exam, just make sure you know how to do this. Now let's actually answer the question. So let me get the question again. It's 1 over sine 30 times tan 60. We now know what sine 30 and tan 60 is. So I'll put this here. So that way we can say that this is just equal to 1 over sine 30 was 1/2 and tan 60 is root 3. So we are here. Now there's a certain form that they want it in, isn't it? They said give your answer in the form of a root b over b. So if I look at this here and I compare this, well, what can I do first? Well, what I will do, let me just put this here just so we have it as a reference, right? Just whenever you're doing like a show that question or you're trying to write something in a specific form, always have it as a reference so you know what you need to work with. Okay, so this one here, I've got a fraction here. This is root 3. I can put this over 1, right? And then how do we times fractions together? We just times across, don't we? 1 times root 3 is root 3. 2 times 1 is 2. So now we're here. Well, there's a lot going on here. We've got a fraction in the denominator. What I can do is change, flip, right? We can keep the numerator the same, change the division to a times, flip the fraction. So we get this here. And then that is just equal to 2 over root 3, isn't it? Because anything times 1 is itself. So this is the answer. Now we want it in that form of a root b over b. So let me write this here again. 2 over root 3. And we want it in this form of a root b over b. Well, if I look at the show that the b has no surd on it, there's no root on it. So how does that happen? How do we go from a surd on the denominator to a non-surd? And that is just by rationalizing, isn't it? So you need to be able to read in between the lines with these types of questions as well. How do I rationalize? How do I rationalize something like this? Well, you're going to times top and bottom by the thing on the denominator, root 3, root 3. And then now doing that, that will equal 2 root 3 over, now remember your surd laws, root a times root a is just root a all squared, which is just a, right? So therefore root 3 times root 3 is just 3. So therefore your answer is 2 root 3 over 3. And you can see quite clearly a is going to equal 2 and b is going to equal 3. And that's it. Finished. Okay, so question 13 says 32 to the power of 5/3 times 2 to the x is equal to 16 to the power of 29 over 12. Work out the exact value of x, and this is a 3 marker. Okay, so with these types of questions, right, or I like to call them, or I don't like to call them, they are called exponential equations. And the reason is because the letter that you're trying to find is in the power. Normally it's on the bottom, isn't it, right? How do we work out these types of questions? Well, what you should notice is if you look at all of these bases here, you can actually rewrite all of them in terms of 2, right? Or the 32 and the 16, the 2 is already in terms of 2. But yeah, that's what you want to do. You basically want to rewrite these. So 32, right, is the same as 2 to the power of what? It's the same as 2 to the power of 5, isn't it? And 16 will just be half of that. So it'll be 2 to the power of 4, right? Now, once we've done that, we can actually rewrite the question. So it's going to be 2 to the 5, all to the power of 5/3, multiplied by 2 to the x, and this will equal 2 to the 4, all to the power of 29 over 12. So we need to work out what this is. Now, what we have here is, well, because we've got one base here, we've got multiple powers, it's a power of a power, we can use our index law, right? What does our index law say about a power of a power? A to the power of b, all to the power of c, means that we just times the powers together, isn't it? So with that being said, if I have 2 to the power of 5, all to the power of 5/3, then that is just equal to 2 to the power of 5 times 5 over 3. And well, what's that equal to? I could put this over 1, and that is just going to be 25 over 3 on the top here, and that will just be 2 on the bottom. So yeah, that one is done. we can write that as 2 to the power of 25 thirds. So that's done. 2 to the power of x we can keep. Now we have to just do this one, isn't it? Now, just from that, we can say, I'll do it here. This one is just going to be, it's just going to be 2 to the power of 4 times by 29 over 12. Again, put this over 1, right? And what you can see is, well, you don't even need to actually times it across. I've got a common factor of 4 here and 4 there. 4 goes into 4 once. 4 goes into 12 3 times. So it's actually just 2 to the power of 1 over 1 times by 29 over 3. Like that, which is just going to be 29 thirds on the power, isn't it? Perfect. So that one's done. We can put that there. So now I can write this. It's going to be 2 to the power of 25 over 3 times 2 to the x is going to equal 2 to the power of 29 over 3. Now, the whole point is of getting it to be the same basis to use your index laws now. Because if you think about it, we're trying to figure out what x is, right? What you can do is actually two ways to do that. I'll show you both. For my index laws, we're doing two powers with the same base, right? If I use our index laws, a to the power of b times by a to the c, then this is just going to equal a to the b plus c, isn't it? So that becomes 22, to the power of 25 over 3 plus x, and this is going to equal 22 to the 29 over 3. So we're here, and now, well, because we have essentially used algebra to get it to this point where we've got two numbers on either side and the bases are the same, well, what must that mean about their powers? It must mean that their powers are equal. If I'm saying 2 to the power of something is equal to 2 to the power of something else, those two powers have to be the same. There's no other choice, right? So therefore we can say that 25 over 3 plus x must equal 29 over 3. So therefore x, if we move that over, x is just going to equal 29 over 3 take 25 over 3, which is just going to be 4 over 3. So x is just 4 thirds. Another way you could have done it is from here, what you could have done algebraically from here is you could have divided both sides by that 2 to the 25 over 3. So you get 2 to the x is equal to 2 to the 29 over 3 divided by 2 to the 25 over 3. And now your index laws, we're dividing it, we take them away. So it means 2 to the x is equal to 2 to the power of 29 over 3 take 25 over 3, which means that 2 to the power of x is equal to 2 to the power of 29 over 3 take away 25 over 3 is going to be 4 over 3. So therefore, you can say that x has to just equal 4 thirds because, again, the bases are the same, so the powers must be equal. So you can do it two ways, and it just depends on what way you prefer. And yeah, that's it. That is question 13 finished. Perfect. Okay, so question 14 says the diagram shows a solid shape. The shape is a cone on top of a hemisphere. The height of the cone is 12 centimeters. The base of the cone has a diameter of 6 centimeters. The hemisphere has a diameter of 6 centimeters. The total volume of the shape is k pi centimeters cubed. Okay, it's an integer. Work out the value of k. And they've given us the formulas for both the volume of a cone and the volume of a sphere. So what do we need to do? They've given us the total volume, right? It's k pi. We just need to work out the volume of the cone, the volume of the hemisphere, add them together, and then we should hope to get an expression which is of the form k pi, which we then can use to figure out what k must be. So firstly, let's do it bit by bit. The cone. I'm going to write cone here. Now, the volume of a cone is given to us. It's equal to 1/3 pi r squared h. Now, what are the dimensions of the cone? The radius is going to be half the diameter, which is 3. The height is going to be 12. So the volume of the cone is just going to be equal to 1/3 pi, and then it's going to be 3 squared times by 12, isn't it? Okay. Now, no calculator. What can we do here? Well, that is 1/3 pi times by 9 times by 12. What is this equal to? Well, 1/3 of 9, we can combine these, can't we? We can do this many ways. 1/3 of 9 is just 3. So that's just going to be 3 pi. And then we're times them by 12. That's just 36 pi, isn't it? So therefore, the volume of the cone is 36 pi. Now, we need to now work out the volume of the hemisphere. I'll write HS for hemisphere. Now, they've given us the formula for a sphere. So be very careful, right? Remember, we don't want a sphere, we want a hemisphere. So to get the volume of a hemisphere, we are going to divide the original formula by 2, aren't we? Now, when you're dividing this here, all you need to do, or what you need to know algebraically, is you just need to half the numerator, right? That 4 on the top is just going to become a 2. So the volume of a hemisphere is just 2/3 pi r cubed, which is what we're going to use, right? So we're going to do it here. Volume is going to be 2/3 pi r cubed, and the radius is going to be the same, isn't it? The radius is going to be 3 because it's attached to the bottom of the cone. So therefore, it's going to be 2 over 3 pi and then 3 cubed, like that. That's 2 over 3 times by pi times by 27. Now, the 27 I can divide by the 3, which is just going to make 9. So, therefore, it's just actually equal to 2 pi times by 9, which is just going to be 18 pi. Perfect. So now we've got the volume of the cone, the volume of the hemisphere. The total volume of the shape is k pi. So what we can do now is just add those together. So I'll do it here. Total volume is going to equal the volume of the cone, which is 36 pi, plus the volume of the hemisphere, which is 18 pi. 36 plus 18 is 54, isn't it? So therefore, the volume is 54 pi. Now remember, it was in the form of k pi. Comparing that, you can see quite clearly that k must equal 54. So therefore, k is equal to 54. And that's it. And that's question 14 finished. Okay, so question 15 says the graph of y equals f of x is shown on the grid below. So we've got the graph given there. Part A says on the grid above, sketch the graph of y equals minus f of x for 1 mark. Now, this one, it's only 1 mark because all you need to know are your graph transformations, and they're not given to you in the formula book, so you need to memorize these. And I've just got a graphic for you guys. I've decided to paste it instead of just making it appear on the video. So this is it here. You need to know these very, very well. So you can stop the video, write it down, or take a screenshot. All you need to know are these, and whatever they give you will determine which one you use, right? So for example, on the grid above, it says sketch the graph of y equals minus f of x. So we're going to go to our table, and obviously you won't get this in the exam. So you're going to look at this in your head because you're gonna have memorized it. Which one is minus f of x? It's the second to last one. What happens to it? It's a reflection over the x-axis, right? And what does that translate to into the coordinates? You just multiply every y coordinate by -1. So for example, if you had y coordinates that are above the x-axis, they will reflect to be underneath the x-axis and vice versa. So what would that mean our graph would look like? Well, we're reflecting it over the x-axis. Well, that means everything is just going to flip, right? So it's going down like this. The new one is going to look like that, right? So how would that look? Let's have a look. Well, that point there, right, is going to be up there, isn't it? So it's going to be like that. And then we can just follow the quadratic essentially. So it's just going to literally be like this, like that, and then like uh like that. And I'm sure you guys will be able to do it a bit better than me. But yeah, literally that will be it, and that will give you the 1 mark. So that's part A done. Now part B. Let's read it. Let me move this out of the way as well. Okay, so it says the equation of the circle is x squared plus y squared is equal to 25, right? The circle C is translated by the vector 0, 5 to give circle B. Draw a sketch of the circle B, right? Label with coordinates the center of circle B and any points of intersection with the coordinate axes. Do you know what I'm going to do? Let me bring that back actually because I'm going to need that later. So okay, now firstly, for us to be able to answer part B, we need to know what the general equation of a circle looks like or what the form is, right? Now, the general formula for an equation of a circle is x squared plus y squared is equal to r squared. There is another form, but you don't need to know it for GCSE, right? You will know it, you will learn it in A-level maths if any of you guys decide to do that. Now, what this has here is you've got a circle. The center of this circle, right, is the origin, 0, 0, and r is the radius, right? So for example, let's say I had an equation x squared plus y squared is equal to, I don't know, 36. Then this would tell me that I would have a circle with the center at 0, 0. And the radius is going to be, well, in this case, r squared is 36. So therefore, the radius, you just square root, is going to be 6. Yeah? So I'll draw a circle with a radius of 6 from the center, and that's it. Now, in this case, the equation of circle C is x squared plus y squared is equal to 25. So in that case, we can see quite clearly that 25 is there. The radius squared is 25, just based on the formula. That means that the radius is 5. So I need to draw a circle which starts at the center. The center is 0, 0, the origin, and the radius is going to be 5, right? So that's what I'm going to go ahead and do now. So I'm going to get an axis going. So let me do it here. So I'm going to get an axis going like this. And then I'm going to draw a circle, right? The center is at the origin, 0, 0. I'll just do it there. And then I'm going to draw a circle like that. And I'm just going to say that the center, the circle's like that, right? Just a rough sketch. Now, what do we know? We know that the radius is 5, right? So in every direction, in terms of vertically and horizontally, it's going to be 5 units, right? Away from the origin. So in this case, the y-intercept here is going to be 5. The y-intercept here is going to be -5. This one's going to be a +5, and that's going to be a -5. So this is our original equation, right? This is x squared plus y squared is equal to 25. Now, we've got a circle B that we need to sketch, and the relationship is that it's translated. This circle that we sketched is translated by a vector of 0, 5. Well, what is the vector 0, 5? What does that do to your graph? It moves it vertically upwards by 5 units, right? So all I need to do is move this vertically upwards by 5 units. So what I'm going to do now is I'm going to copy this. Let me copy this here. You know what I'm going to do actually, just so it's super neat, right? And just so it's clear. Let me copy this and then let me just put these here. So that should be, let me delete this actually now. Okay, so this one here is x squared plus y squared is 25. And now this one is going to be the translation, right? This one is a translation of 0, 5, right? Everything's going to move upwards by 5 units. So what would that mean for the graph? Okay, well, let's see. Well, remember, if I move vertically upwards, right, every y coordinate is going to be shifted up by 5, right? So if I move this upwards 5 units, the -5, if I add 5 to -5, it would go to 0, wouldn't it, right? So it would go up there. The center, which was originally at 0, 0, would go up by 5 units. So that would be 0, 5. And then the new y-intercept, right, of this one here is going to be, actually, I need that there. I need to just make it a bit bigger. So what I'll do is I'll just extend it like this, to be honest. Doesn't really matter, like that. This one here is now going to go to 0, 10. So let's just compare it actually and see. So I'm going to rub out these ones because there's going to be no x-intercepts anymore, as you can see from the picture. Now, this one was -5. If I add 5 onto it, if I add 5 onto -5, it will be at 0, 0 now. So it's going to be the new lowest point, right? Now, the center was at 0, 0. Remember, we're moving it vertically upwards by 5 units. So the new center is going to be over here at 0, 5. And then the highest point here, which was at 0, 5, we're going to add 5 onto that. So it will now be at 0, 10. So we've got all of the points now that we need because the question did say, label with coordinates the center of circle B and any points of intersection with the coordinate axes. Now, the only intersections now is going to be with the origin here, right? And this and the y-axis here. There's going to be no intersection points here, is it? With the x-axis, so we don't need to label anything there. So yeah, that would literally be it, and that would be your answer to this question. Finished. Okay, question 16 says ABCD is a quadrilateral. AB is equal to AD, BC is equal to CD. Prove that line AC bisects angle BAD, and this is a 4 marker. Okay, now firstly, what I would do with this type of question is I would actually annotate the diagram and put where AC is. Well, AC is just this line here, isn't it? And the angle BAD is going to be this one, like that. And we need to prove that this line bisects this angle. Well, if it bisects the angle, then that would mean that this angle on this side, right, in green, would have to be the same as this angle on this side, on the right, right? Because it's splitting it down the middle, right? If it is bisecting it. Now, how can we prove that? Well, due to the fact that we've split it down the middle here, we've got 2 triangles, right? And these angles are just one of the angles in both triangles. So what topic comes to mind when you see these types of questions? Well, it should be congruence, right? How can we prove angles are the same? We can prove that the triangles are congruent. If we can prove that the triangles are congruent, then naturally the angles in the triangles would be the same. So with the sides, right? So let's see if we can prove that these 2 triangles are congruent. Now, what about the information given in the question? And even before that, remember your four different types of congruents, right? You've actually got RHS. Let me write here. You'll have RHS, you're gonna have SAS, you're gonna have SSS, and you're gonna have ASA, right? This is right hypotenuse side, this is side angle side, this is side side side, and this is angle side angle. So to prove congruence, we need to show that it's one of these four. Yeah. Now we've got the two triangles. Let's look at the information in the question. AB is equal to AD. Well, AB is there, AD is there, right? So step one, that is one side. I'm going to write here, AB is equal to AD, right? That's one side. Now, second bit of information, BC is equal to CD, right? That's another side. I'll write this here. BC is equal to CD. Now, what else do we have? Well, what about the side that we haven't looked at? Well, both of the triangles share this line AC, don't they? Right? We have that side AC on both triangles. So what I'm going to say is number 3, I'm going to write another side and then I'm going to write in brackets, both triangles have AC in common. AC in common, right? So therefore, the triangles ABC and triangle ADC are congruent because it's side, 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 right? So therefore, what I'm going to say and actually what you should do, just to be super clear, right? On top of this, just be clear to the examiner. Just say, consider triangles, ABC and ADC, right? Just so the examiner knows which two triangles you're dealing with. Okay, now we're considering those two triangles and we've shown that each of them have the same side, right? Side, side, side. So therefore, what we can say from here is that therefore, triangle, all right, triangle for like that. I try that symbol. Triangle ABC and ADC, right, are congruent. Now, since they are congruent, remember that must mean that all of these angles here are the exact same, right? They all have the exact same angles. So that would say, so now we could say then is that those two angles, right? Angle DAC, the green angle, right? Must be equal to angle BAC, right? Because they are congruent. And now since these two angles are the same, that must mean, all right, therefore, the line AC, whoops, sorry, that again. The line AC, I wrote AA. The line AC bisects the angle BAD. And that's it. Finished. Okay, so question 17 says, given that 10 minus root x times 5 plus root x is equal to y root x plus 39, where x is a prime number and y is an integer, find the value of x and the value of y. Show each stage of your working clearly. And this is only a 3 marker. Right, so these two are the same. What I would do is say, well, fine. The left-hand side is a lot more to work with. I've got brackets, right? So I'm just going to actually expand it and see what happens. So if I expand that here, so that would be that and that. That's going to be 50. 10 times a root x is going to be a 10 root x. And then minus root x times by 5 is going to be a minus 5 root x. And then a minus root x times a root x. Remember, there's a minus there. Root x times root x. Remember your surd laws. It's just x, isn't it? The roots will cancel. So I just have this here. Now, what can I do once I've expanded? Well, let me just tidy this up a little bit, right? I've got 50. Those two terms of root x can simplify. 10 lots of root x, take away 5 lots of root x, will just leave you with 5 lots of root x altogether. And then we're taking away x. Now, this is the left-hand side. Now, we know that this is equal to the right-hand side, y root x plus 39. So what I'm going to do now is I'm going to put this equal to this side. Now, when you get here, what we're going to do is we're going to use a little tool called comparing coefficients, right? And what that means is if two things are the same algebraically, left side and right side, it must mean that the coefficients are equal as well. So I'll just give you an example. So let's say, for example, I had, I don't know, let's say I had 4x plus 3y, right? And I'm saying that this is equal to ax plus by, right? Since these are the same, right, it means that the coefficients, the numbers multiplying the terms here, right, they have to be the same, right? That 4 has to equal the a, and then this b right here, this 3, right, must equal this b. Right? And that's exactly what it means. And we're just going to make use of that. So what you want to do is just put it into the same structure. So what I'm going to do, I'm going to just move this to the side here. I'll just move this over here. Why not? And then what I'm going to do is I'm going to get this in the same structure. So firstly, I've got y root x, right? I'm going to put the 5 root x first. So it becomes 5 root x. And then I'm going to have plus 50, take away x. And then this is going to equal y root x plus 39. Like that. Now, comparing, well, if this is the same thing, think of these as two terms. This is my root x term here, right? And then this here is going to be my number, right? Because x is an integer, that must mean that this has to be the same, right? So if I compare those, well, I've got the root x here, I've got the root x here. The coefficient of root x is that y, right? And if I look on this side, that is 5. So I can just say from there, y must equal 5. Perfect. So we've done that. Now, the next part, right, is 50 take away x. Now, although x is a variable, it's a letter, right? X is an integer. So 50 take away an integer is still an integer. On the right-hand side, the integer is 39. So that must mean that that 50 minus x must equal that 39, right? So I could create an equation here. I could say that 50 take x has to equal 39. And then, well, this is just a simple linear equation that we can solve. So I'm going to add x to that side. I'm going to take 39 to that side. It's going to be 50 take 39. It's going to equal x, isn't it? And that just means x is equal to 11. So therefore, we now know what x and y is. So the actual expression on the right-hand side becomes y, which is 5. 5 root x is 11, like that, plus 39. And that's it. That's 3 marks. And that is our question 17 finished. Okay, so question 18 says f, g, and h are functions such that f of x is equal to x squared minus 4x plus 7, g of x is equal to x minus 5, and h of x is equal to root x plus 3 over 2. Part A says we need to find f of g of 1 for 1 mark. Okay, so firstly, composite function. G of 1, right, is closest. So g is closest to that number 1. So that tells me that I have to plug in g of 1 into f. So I'm going to figure out what g of 1 is. And that's just going to be 1 take away 5, isn't it? Which is minus 4. So now g of 1 is minus 4. That minus 4 is going to go into our function f. So it's going to be f of minus 4, which is going to be minus 4 all squared, minus 4 lots of minus 4, plus 7. Now, be careful, you have no calculator. Minus 4 all squared is minus 4 times minus 4. Those are two negatives. That's going to be a positive 16. And then that's just the same thing with this one. That's going to be another plus 16. And then we're adding on 7. 2 16s are 32. 32 plus 7 is 39. So therefore, f of g of 1 is just 39. And that's the first part done. Part B says we need to find the inverse of h. Remember, h to the minus 1 is just the inverse. So how do I find the inverse of a function? What you should always do is set your function equal to y. So change the notation. Change it from function notation to just x and y. So I'm going to say y is equal to root x plus 3. And I'm going to divide this by 2. Now, what you do here is you're going to swap x and y around. You're going to interchange x and y. So x is going to equal root y plus 3 all over 2. Now, once you get to this step, all you need to do to figure out what the inverse is rearrange to make y the subject. So what would I do from here? Well, firstly, I've got that division of 2. I'm going to multiply it up. So it'll become 2x is equal to root y plus 3. Now, be very careful. We're trying to get y on its own. We've got that square root, right? Think of that as like a wall, a shield. You can't do anything with the y plus 3 unless it's gone. So we need to get rid of that root, and we do that by squaring. So I'm going to square both sides. Square both sides. The right-hand side will just cancel the root, so it'll be y plus 3. Now, be careful. 2x all squared, right, is 4x squared, right? You square both of the terms inside. Sometimes I see students will just put 4x and they forget to square the x. So just be very, very careful, right? Even just write it out. Remember, 2x all squared is just 2x times another 2x. 2 2s are 4, x's are x squared. Yeah, so perfect. That's done. Now, remember, we're trying to find out the inverse, so we need to make y the subject. We just need to take 3 away. So it's going to be 4x squared, take away 3, and this is equal to y. Now y is the subject. We can replace y with the inverse of h. So therefore, your answer is going to be h to the minus 1 of x. The inverse of h is going to be 4x squared take away 3. And that is it for part B. Now, part C. It says solve g of f of x is equal to 6. Give your answer in the form of a plus or minus b root 2, where a and b are integers. And I've just got the two functions set up here, just so we don't need to keep going up and down. So we need g of f of x, right? Now, what I like to do with these questions is I'm going to write g of f of x again, and then I like to put a bracket around it, like that. That tells me what is going into what, right? Our function f is going into g. So our input is going to be f of x for g, right? So if I just follow this structure, the input here is x. It's x take 5. Since our input is now f of x, we replace this x with f of x. So it becomes that. Now, what does that mean? Well, our function for f is just x squared minus 4x plus 7. So all we're going to do is we're just going to say that g of f of x then is just going to be f of x, which is x squared minus 4x plus 7. And then we're going to take away 5. And remember, this is equal to 6. So I can actually set this equal to 6. And what we have here is just a standard quadratic equation. So we just need to get it in the form. Now, what I'm going to do is before I start doing the algebra, look at the form that they want it in. A plus or minus b root 2. When you see that type of form, that tells you that naturally it's probably not going to be able to factorize. You're going to need to use another method of solving the quadratic, which is either completing the square or the quadratic formula. I will use the quadratic formula just because I think it will be the most common form used if you can't factorize. So let's tidy this up. It's going to be x squared minus 4x, and then 7 take away 5 is 2. And then this will equal 6. And then now, remember, we can move this over to the left. So it's going to become x squared minus 4x. 2 take away 6 is minus 4. This is equal to 0. Now, again, once you get here, have a look at this number, minus 4. 2 factors of minus 4, which will add to make positive 4. Sorry, add to make negative 4. It won't work. Minus 2 and 2, right? Because we need one of them to be positive for it to be negative overall. It's not going to work. So it doesn't factorize. And yeah. So now you know it doesn't factorize for certain. Let's use the quadratic formula. So what is the formula for the quadratic formula? It's x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Now that just means we need to identify our a, b, and c, and that's easy. If I put a 1 there, then we can see that, and obviously this is when you're comparing it to ax squared plus bx plus c, isn't it? Is equal to 0. So a is going to equal 1. B is going to equal negative 4, and so will C, wouldn't it? So now we've got A, B, and C. We can just plug it into the quadratic formula here. So it's going to be x is equal to minus b. B is minus 4, so there's two minuses there. Plus or minus b squared, which is going to be minus 4 all squared. Take away 4 lots of A, which is a 1, times C, which is minus 4. And then this is all over 2 lots of A, which is 1. So we just need to evaluate that, bearing in mind we need it in that form of a plus or minus b root 2. So let's evaluate. What do we have here? Well, two negatives will make a positive. So it's going to be positive 4 plus or minus. Now this one, be careful. Minus 4 all squared is minus 4 times minus 4. That's positive 16. And then we've got a minus there and a minus there. That's going to be a plus. The 4 times 1 is 4 times another 4 is going to be 16 again. This is all over 2 times 1, which is 2. So from here, we can say then that that's just going to be 4 plus or minus 2 16s are 32 all over 2. All right, now we're here. Remember, we want a root 2, right? From the form that they want it in. We've got root 32. So what comes to mind now? Surd laws. Remember, the surd law, I'll do it here. Root a times b is equal to root a root b, isn't it? Which means that root 32, we can actually write as root. Think of two factors. You always want to choose factors that are square numbers. And if you've got an option of 2, you pick the larger one. So the largest square factor of 32 is 16. 16 times 2 is the same as root 16 root 2, which is just 4 root 2, isn't it? So that way, we can actually replace root 32 with 4 root 2. So with that being said, I'll just do it here. It's going to be 4 plus or minus, and then 4 root 2 over 2. And then now we're here. We've got a fraction. We can just literally separate them. 4 over 2 plus or minus 4 root 2 over 2. 4 divided by 2 is 2. Plus or minus 4 divided by 2 again is 2. So it's actually 2 root 2. So therefore, the answer is 2 plus or minus 2 root 2. And A and B are both equal to 2. So that will go there. And that's it. That's question 18 finished. Okay, so question 19 says a bowl contains n pieces of fruit. Of these, 4 are oranges and the rest are apples. 2 pieces of fruit are going to be taken at random from the bowl. The probability that the bowl will then contain n minus 6 apples is 1/3. Work out the value of n, show you're working clearly, and this is a whopping 6 marks. Okay, so firstly, what are we dealing with here? We've got 2 pieces of fruit being taken, right? So there are 2 types of scenarios, take 1, take 2. There's probability involved. What can I do to visualize this question? We've got probabilities, we've got things being taken. This is just a classic probability tree question, right? So what I would do first is visualize this. I'll get a probability tree going to see what I can do. So firstly, I'm going to do branches like this. I'm going to do a branch like there and a branch like that. And then I'm going to call this O for oranges and then A for apples. And I'm going to call this my first take because we're taking 2 pieces of fruit. And then my second branch is going to be this one for the first take being orange, O, A, and then the second take like that. And then this is my second take if I were to take an apple on my first go. So O and then A. And then what I'm going to do is label it, right? And well, to label it, I need the probabilities. So what do I know? Well, a bowl contains n pieces of fruit. So I know that there was a total of n fruit. So I'm going to say the total is equal to n. Of these, 4 are oranges and the rest are apples. So I'm going to say oranges, right? That will equal 4. Now, if there are 4 oranges, well, we don't know how many apples there are, but can we express that algebraically? For sure. Let's just say the apples are x, right? Then we agree that the total is going to be the amount of oranges there are plus the amount of apples. So I'm going to say that 4 plus x must equal the total, which is n. And then I could just rearrange this algebraically to say that x must equal n take 4. And this is helpful because now I've got an expression for apples in terms of n. I can now complete my probability tree, right? We don't have the actual probabilities, but we've got them algebraically, which is a step, right, in the right direction. So let's label this and see what we get. Well, what would the probability of me taking an orange on my first go be? Well, how many oranges are there? There are 4. What is it out of? It's out of n. That's fine. What would be the probability of me getting an apple? Well, it's be n take away 4 over n. And then now we've got to do the second takes. Now let's start with the first one where we assume that we've taken an orange on our first go. If we've taken an orange on our first go, then there's going to be 1 less orange to pick from. So we're going to change the 4 to a 3. And well, if we've taken an orange, we've taken 1 fruit. So there's going to be 1 less fruit as well overall. So it would be n minus 1. So that's done. And now, what would be the probability of me taking an apple on my second go? Well, remember, we're assuming that we've taken an orange on our first go, meaning that the amount of apples hasn't changed. So we're going to have n minus 4 here. But remember, this is still on our second take. So there's going to be 1 fewer piece of fruit in general. So it's going to be n minus 1 here as well. And then now let's do the second branch underneath. So we're assuming here that we're taking an apple on our first go. So if you take an apple on our first go, then what would be taking a second apple? Well, what I would do here is just be very careful, right? At the start, there are n minus 4. If I take an apple, I'm taking 1 away from this expression here. That's going to be minus 4 minus 1, which is going to be minus 5, isn't it? So just be careful. This is an n minus 5. I know some students, sometimes you could go the other way and think it's n minus 3, but then you'd be adding, wouldn't you? Yeah. So it'd be n minus 5. And then remember, it's going to be over n minus 1 because this is our second take. And then remember, if I take an orange on my second go and I've taken an apple on the first, the amount of oranges hasn't changed. So it's going to be 4 over n minus 1. Perfect. So now we've got our probability tree. And let's look at the question again. 2 pieces of fruit are going to be taken at random from the bowl. The probability that the bowl will then contain n minus 6 apples is 1/3. Okay, well, what does that actually mean, right? Because they've given us a probability, 1/3. But what does it mean if there's going to be n minus 6 apples after 2 pieces of fruit are taken? Well, let's deal with the apples, right? What I'm going to do is I'm going to go here. Now, I'm actually just going to write this. So let me write this here. And I'm going to write at the side of n minus 4, I'm going to write this is at the start, right? There are n minus 4 apples. Now, on my first take, if I take an apple on my first go, there's going to be one less apple to choose from. So I'm going to take one away from n minus 4. That will give me n minus 5. And this is the amount of apples that there are. So let me write apples here as well. And apples here as well. So after my first take, there's going to be n minus 5 apples, assuming I've taken an apple on my first go. Now, if I was to take an apple again, second take, right, and it's an apple, then I would just take one away from n minus 5. N minus 5 minus 1 is n minus 6. So we get that expression of n minus 6, right? Which is what they've told us in the question. Now, what does this n minus 6 mean in context? Well, we can see quite clearly it means that we've taken 2 apples. So this sentence here is just a fancy way of saying that you're taking 2 apples, right? But they've kind of made it a bit trickier to dissect, right? They're just trying to trip you up. But essentially it's just saying that you're just taking 2 apples, right? So what I'm going to say then is that, well, that sentence that looked a bit fancy is just the same as saying that the probability of taking 2 apples is just equal to a third. So what do I do from here? Well, what would be the probability of me taking 2 apples? Well, let's look at our probability tree. Remember, if you're taking anything from a tree, right? Well, you just go along the branches. If I take an apple on my first go, right, then it's n minus 4 over n. And then remember, when you go along the branches, you just times the probabilities together, right? So I need to times these two together, and that will be the probability of me taking 2 apples, right? So what we can say then is that from there, n minus 4 over n multiplied by n minus 5 over n minus 1 is just equal to a third. So now I'm here. What do I need to do? Well, remember what we're trying to find. We're trying to find the value of n. So this is just an equation here. We need to figure out what n is. So what I'm going to do first is I'm actually going to expand the brackets, right? So if I put a bracket like this and a bracket like this, then if I expand the numerator, it's going to be n times n, which is going to be, let me draw a fraction line as well. That will be n squared. N times minus 5 is minus 5n. Minus 4 times n is going to be a minus 4n. And then minus 4 times minus 5 is a positive 20, right? Now, the bottom is just n times n minus 1. That's just going to be n squared. N times minus 1 is going to be minus n. And this is equal to a third, right? Now, this is good because we formed an equation, right? Which is what we had to do. Now we just have to figure out what n is. So now I can simplify the numerator a bit. So n squared minus 5 minus 4 is minus 9. So it'll be minus 9n plus 20 over n squared take n. And then that will equal a third. Okay, so now I'm here. You're dealing with an algebraic fraction, guys. Now, what you want to do when you're dealing with an algebraic fraction is get rid of the fractions, right? Because you're not able to move things around when it's in a fractional form. So what we need to do is get rid of them. So you want to cross multiply. That 3, you want to multiply with that numerator, n squared minus 9n plus 20. And this n squared minus n, you're going to times up to join that 1. So I'll just finish it off here. Let me just grab this here. And then we can continue. So we are here. Now, cross multiplying, that looks very nasty to be fair, doesn't it? Let me make it a bit neater. So we're just doing that times that. That's a bit better. So it's going to be 3 and then n squared minus 9n plus 20 is going to equal 1 and then n squared minus n. Now let's expand the brackets. 3n squared minus 27n plus 60 is going to equal n squared take n. Now, what type of equation do we have here? It's a quadratic equation because the highest power of any variable is 2. So how do we solve quadratic equations? You move everything from one side to the other. You want to make one of the sides 0. Always choose the side with a positive n squared term to be the side that you move everything to. So I'm going to move everything from left to right. So if I do that, then the n squared, if I take that from the 3n squared, that will just give me 2n squared. And then if I do this one, this minus n will turn into a plus. I'm going to add on n to minus 27n. That would be minus 26n, wouldn't it? And then that would just be plus 60. And then it equals to 0. So we are here now. Now, what do we do from here? Okay, well, look closely. You've got an even factor in each of these terms. So you may be thinking, well, I've got a number in front of the n squared term. Maybe the HCF method will do 2 times 60, but you don't need to do that. You can just divide every single term by 2, and that will make life a lot easier. So it becomes n squared minus 13n plus 20 is equal to 0. Now, we've just got a standard quadratic. Sorry, not 20. that would be 30, isn't it? Apologies. Perfect. So that's going to be a 30. Now, what can we do from here? Um, can we attempt to factorize? For sure, right? Well, if I look at this factor here, I need two factors of 30, which are going to add to make minus 13, isn't it? And that's just going to be, they're going to be both negative because this is negative. It's going to be a -3 and a -10, isn't it? Because -3 times -10 is positive 30. -3 plus -10 is going to be -13. So that way, we're going to just factorize, and this will equal 0. We're going to have n here, going to have n here, and then you're just going to put those two numbers in. -3, -10. Now, to solve it, remember, when you get to this step, you make each of these brackets equal to 0. So n minus 3 is going to equal 0, or n minus 10 is going to equal 0. So therefore, n is going to equal 3, or n is going to equal 10. So we figured out the values of n. Now let's go back to the question. What does the question say? It says work out the value of n. So that's singular, isn't it? There's one value of n. So what I'm going to do is let me grab everything that I have here. So how do we figure out what that value of n is? So let's see the question. So put that there. And then let's look at the information they told us about n, right? The very first two sentences, right? So because most of the time when you see types of contextualized questions and you get two values of n or x or whatever it is, one of them is negative and it's just easy to figure out which one it is. But let's read it. A bowl contains n pieces of fruit. Of these, 4 are oranges and the rest are apples. Now, from that sentence alone, 4 being orange and the rest being apples, that tells me that the total amount of oranges, right, must be more than 4 because 4 of them are oranges, right? Now, we've got two values. We've got n equals 3, and this is n equals 10, right? The total amount of oranges is n. How can there be 4 oranges, right? But n is equal to 3. That does not make sense. So it cannot be this one. So the answer is n is equal to 10. And that's it. And you could just say, just to be very certain for the examiner, since there are 4 oranges, right? N must be greater than 4, right? So therefore, n is equal to 10. And that's it. And that's the question 19 finished. Okay, so question 20 says OAB is a triangle. O to A is equal to 2A. O to B is equal to 2B. M is the midpoint of AB. N is the point on OB such that O to N and N to B is equal to 2 to 1, the ratio. P is the point on AN such that OPM is a straight line. Use a vector method to find the ratio of O to P and P to M. Show you're working clearly. And this is a 6 marker. Now, firstly, what I'd want to do with a question like this, right, is let me get this diagram. I'm going to copy this diagram a couple times just so we can actually just nicely annotate it, right? Now, whenever you're dealing with these types of questions where they're asking you about a ratio, right? Essentially, what you want to do is essentially investigate the line in question. So O to P and P to M. If I could figure out what fraction of this line O to P is out of the entire line, then it would allow me to figure out what this fraction is here, and then that will give me the ratio. So essentially what I want to do is figure out expressions for O to P, right? Now, what can I do here? Well, firstly, let's look at the information given in the question, right? We know that O to A is equal to 2A and O to B is 2B. So let's label that. That is, I'll put an O here. That is a 2A, and then this one is 2B. Now, the first sentence after that says M is the midpoint of AB. Now, for me, that tells me I can calculate what the vector A to M is because A to B, right, just by looking at it, right, is going to be equal to going from A to O, right, which is going to be minus 2A, and then plus O to B, which is going to be 2B. Now, A to M is half of that, isn't it? Because it's the midpoint. So it's half of A to B, which is equal to that. So it's going to be half of minus 2A plus 2B, right, which is just going to equal minus A plus B. So now I know what the vector A to M is. So now I know what that vector A to M is, minus A plus B. Well, how does that help us? Well, what other piece of information do we have here? We can also see as well, right? Remember, we're trying to figure out what the vector O to P is, right? So what I can do is say, let me get another triangle, right? There's a couple of triangles here. I'm going to break this down. I'm going to draw the triangle AOM, and you'll see why. AOM, which is going to look something like that. Now, this is A. That's A. So let me just go down. That's A. That's O, and then that is M. Now, what do I know? I know O to A is 2A. Now, O to M I don't know, but I do know A to M. I've just worked that out. That's minus A plus B. So what that does is it allows me to figure out what O to M is, right? Which is one of the ratios, which is the line in question, right? That we need to find the ratio of. So O to M, just by looking at this here, we can see quite clearly it's just going to be going along O to A and then along A to M, which is going to be 2A plus and then minus A plus B, isn't it? So therefore, that's just going to be 2A minus A is an A. This is just A plus B. So O to M is going to equal A plus B. Now, remember what we're trying to figure out? The ratio of O to P and P to M. Now, if I look at the diagram, remember P is just going to be somewhere along here, right? Now, we can see quite clearly that O to P is a fraction of the entire line O to M, right? So what I can say is that the vector O to P, right, is going to equal some multiple of O to M. Now, that multiple is going to be a fraction, isn't it? Because it's actually shorter in length. And I'm going to call that multiple mu, right? It's going to be a fraction of it. So I'm going to call O to P mu, and then it's going to be A plus B, right? Because that is what O to M is equal to. So now I can say that O to P is equal to mu A plus B. Now, as well as that, let's look at the rest of the information of the question, right? What else haven't I used? Haven't used these two sentences, have I? So these two sentences here, I'm gonna use that and then see what I can get. So I'm gonna put this on the side here, and then if I need more space, I'll just go down. So I'm gonna get that triangle again as well. So let's see how this helps us. So it says n is the point on OB such that O to n and n to b is in the ratio 2 to 1. P is the point on AN such that OPM is a straight line. So remember what we know already. We know that this was 2A. We know that this entire line O to B was 2B. Now O to n and n to b is in the ratio 2 to 1. That means that this part O to n is going to be 2 parts out of 3. Remember 2 plus 1 is 3, 2 out of 3. And then this part is going to be 1/3. Now, if 2b is the entire vector, then I can find the vector for O to n. It's going to be 2/3 of 2b, isn't it? And this one is going to be 1/3 of 2b. And that there means that, well, let me rub this one out. That means that O to n is just 2/3 times 2 is going to be 4/3. This is 4/3 b. And then this is 1/3 times 2, that's 2/3 b. So I now have vectors for O to n and n to b. Now, how does that help us in general? Remember, we're trying to figure out what, let me put an O here. Trying to figure out what this vector O to p is, right? What that multiple. Remember, we said it was mu A plus B, right? Now, what we want to do is maybe figure out another way of expressing that vector O to p. And that way we can use simultaneous equations, right? So it's a very tricky question, but just keep going. So what I'm going to do now is the fact that I know that O to n is 4/3 b, I'm going to draw another triangle, right? I'm going to draw another triangle, which is going to be something like this. And this is going to be the triangle of A, N, like that, and then O, right? Now, what do I know? This vector is going to be 2A, and I now know that O to n is 4/3 b. That will allow me to calculate what this vector A to n is, right? So what would that vector A to n be? Well, it's just going to be, I'm going to go along A to O, which is going to be minus 2A. And then I'm going to go along A to n, which is going to be 4/3 b. Now, remember, they told us that P is a point on AN such that OPM is a straight line. So that means O to P is going to be here, isn't it? And the reason why this is helpful is because now I can figure out another way of expressing that vector O to P, right? Remember the original way of O to P was mu A plus B. I can say just by looking at this diagram that O to P is going to equal O to A plus A to P, isn't it? Right? Now, A to P, remember, if you look at this diagram here, is a fraction of the entire line A to n, which we know the vector of. So what I'm going to say is that A to P is going to be some multiple again. And I'm going to call this multiple lambda, like that. And then now I'm going to say that this is just going to be a multiple of the entire line, which is A to n. So I'm going to put minus 2A plus 4/3 b in there. And that is an expression for A to P, which means now I can build up and make another expression for O to P. O to P is going to equal O to A, which is 2A. And then I'm going to add on the vector A to P, which is going to be lambda, and then minus 2A plus 4/3 b. Perfect. Now, we've got two expressions for O to P. Now, why is this helpful? Remember what the question is asking us to find. They're asking us to find the ratio of O to P to M. If I could figure out what that multiple of O to P is, right, of the entire line O to M, then that will allow us to figure out what P to M is. And we can do that by using algebra, right? So what I'm going to do is I'm going to highlight that expression of O to P. I'm going to put this here. And then that other expression of O to P which we found is this one, right? This is O to P as well. And I'm going to put this here. And then what we want to do is figure out what that multiple of mu is, right? Because if we could figure out what that is, that will tell us the fraction of O to P out of O to M. Now, algebraically, these vectors are the same. So what I can do is make them equal to each other, can't I? So I'm going to say mu A plus B, right, will equal 2A plus lambda minus 2A plus 4/3 B. Now, since these vectors are the same, right, it must mean that the components have to be the same, the multiple of the components, which are A and B. Now, what I'm going to do is I'm going to set this up so that the left side is a vector A plus a vector B, and the right side is a vector A plus a vector B. So what I'm going to do is I'm going to expand. I'm going to have mu A plus mu B on the left side. And on the right-hand side, if I expand that lambda, it's going to be lambda times the minus 2 will be minus 2 lambda A. And then the lambda plus the 4/3 would be 4/3 lambda and then B, wouldn't it? Now, remember what we want to do? We want to set it up so that it's in the form of XA plus YB, right? For both sides. This side, the left side is done. The right side isn't though, because I've got two A's here. But that's not a problem. I'm going to factorize it out. And normally we put the A on the left, but I'm going to put it on the right and you'll see why. Now, what would go inside the bracket? It would just be 2 take away 2 lambda, isn't it? Right? If I expand that, I'll get the same thing. And then I've got 4/3 lambda and then B. And I'm going to put a bracket around each of these and you're going to see why, right? So this side was fine, but I'm going to put a bracket around it anyway, like that. And then a bracket around that as well. Now, remember, these two vectors are both O to P, isn't it? O to P, like that. And then this is O to P, like that. Now, if these two vectors are the same, it must mean that the numbers multiplying each vector component have to be the same. So that mu must equal this 2 minus 2 lambda, right? And then this mu, right, must equal the 4/3 lambda. So we can actually create two equations and we can solve simultaneously. So I'm going to say from there that mu must equal the 2 minus 2 lambda. And then this one, mu, is going to equal the 4/3 lambda, isn't it? And then from here, well, because mu is equal to 2 minus 2 lambda, and mu is also equal to 4/3 lambda, that must mean that the 2 minus 2 lambda, right, must equal to 4/3 lambda, because they're both equal to mu, right? And now what we can do is figure out what lambda is. Once we know what lambda is, we'll be able to figure out what mu is, and we're pretty much done. So what do I do from here? Well, I don't like this division of 3. I'm going to times all of the equation by 3 to get rid of any fractions. That would mean this will become a 6 minus 6 lambda, and then that would just be a 4 lambda. And then now I can move this 6 lambda to the right by adding it on. That will be 6 lambda is equal to 4 lambda plus 6 lambda, which is just 10 lambda. So therefore, 6 is going to equal 10 lambda. And then that means that 6 divided by 10 is equal to lambda, isn't it? Which means that lambda is equal to 6 divided by 10 divided upon bottom by 2 is just 3/5. So now I know what lambda is. This is helpful because remember, mu was in terms of lambda. That will allow me to figure out what mu is. So if mu is 4/3 lambda, then mu is actually equal to 4/3 times lambda, which is 3/5. Then that way we could figure out what mu is. This is very easy because now the 3's are going to cancel like that. And you're just left with 4/5. So now I know what mu is, that multiple of that line, right, in O to P. So let's just go back to the original diagram here. Remember, O to P was a fraction of that line O to M, wasn't it? We wanted to figure out what that fraction was. We now know that mu is equal to 4/5. So this line is just 4/5 of the way along O to M. And if that's 4/5 of the way, that must mean that this part is 1/5 of the way because there's 5 parts, isn't it? 1/5. So the question, let me get this diagram again because we're pretty much done. Copy that there, and I'll just do it here. So this is where we're at. We now know what the fractions are for each side. What did the question ask us for? It says use a vector method to find the ratio of O to P and P to M. So now, if I look here, we now know that mu was 4/5, which means that that side is going to be 1/5. So what would the ratio be? Well, it's very easy. It's 4 to 1. But what you could do is just say, well, it's going to be 4/5, right? To the ratio of 1/5, right? That's O to P. That's P to M. Now you could just times by 5, can't you? So it becomes times by 5 on both sides. So it's just going to be 4 to 1. And that is it. And that is the answer. And that is question 20 finished. Hey guys, Daniel here. Hope you guys are doing well. So yeah, that's the end of the paper. Couple of tricky questions in there. Hopefully you guys found it helpful with your revision. I try to reflect the actual type of a paper that you'll get in a real exam, where obviously the level of difficulty increases. But yeah, hopefully you had a go at the paper, and then obviously you've gone through the video now, and any misconceptions or anything that you found a bit tricky, the video has helped you clarify that. And yeah, just guys, just keep doing what you're doing. There'll be 2 more papers coming out. So there's going to be a paper 2 after paper 1, and then a paper 3 after paper 2, just to help you a bit more with your revision. And yeah, just keep doing what you're doing. Couple of things, I will be running some extra classes in May, so definitely keep an eye out for that. Also, I have a couple of courses on my website now that you guys may be interested in, so I'll also put a link in the description for that as well. But yeah, that's pretty much it. Again, if you found the video helpful, it would be brilliant if you could like, comment, subscribe, share with your friends, and yeah, just keep on going, guys. We just keep on going, keep doing what you're doing. So proud of every single one of you. You guys are gonna smash paper 1, and yeah, I'm sure you guys will let me know how it goes. Until then, take care. Bye bye.